45 minutes long. And for the presenters, we have only 10 minutes time limit. This is why I will ask all speakers be very strict on timelines. The first speaker is Jan Fogg, who is the director of network studies of the International Associations for Mobile Communications. Let us welcome Jan Fogg.
Floor is yours.
I'm here. Can you hear me okay?
Yeah.
And can you see the slides okay?
Yeah, it's visible. Thank you.
Great. Thank you. Thank you for the introduction. I will endeavor to keep to time. So today I'm going to present briefly on the global status of 5G Advanced, 5G Standalone, and 5G RedCap. This is part of the work of the Global Mobile Suppliers Association, the GSA, which is the industry voice of the global mobile ecosystem. We have a number of working groups around spectrum, private mobile networks, a new RedCap group, and a fixed wireless access group. This organization is open to membership from across the industry, and that provides access to member-specific reports and the Gambod database from which much of the data that I am presenting today comes. We publish more than 160 reports annually on our website, covering a range of topics that apply to the ecosystem, including devices, NTN, non-terrestrial satellite, non-terrestrial network, operator adoption of technology, spectrum auctions, chipsets, spectrum assignments, RedCap, and network technology. Today, I'm going to look at the momentum for 5G Standalone, which is a foundation for RedCap and 5G Advanced. I'm also going to look at the state of the market globally for RedCap and 5G Advanced, covering both operational investments, chipset, and device support. The presentation includes data from 2 recent GSA reports on 5G Advanced and 5G RedCap. 5G Standalone is a vital foundation for all of the topics I'm going to talk about today. It is essentially real 5G, where a device connects to a 5G core network, and that enables a range of new capabilities. The GSA currently is tracking 163 operators in 65 countries or territories that are investing in 5G Standalone. Sorry. We also identify 73 operators in 40 countries that have launched commercial 5G Standalone services to date. And we've been tracking growing momentum in this in recent quarters. And this again is from our recent report. 5G RedCap is a technology that requires an operator to have 5G Standalone. It also is based on the 3GPP Release 17 standard. The goal of the designers of RedCap, or Reduced Capability 5G, is to lower the cost for 5G, particularly in terms of the end user device, the user equipment, by lowering the capabilities, the requirements in terms of the antenna, the processing, and so forth. But importantly, 5G RedCap enables access to 5G specific spectrum, particularly spectrum in the 3 to 6 gigahertz band. It also enables operators to manage RedCap on a network slice, so offer improved or assured or guaranteed network performance, and enables other aspects of the technology. So it is an enhanced offering compared to a 4G era technology, even if the average speed may sometimes be quite similar. So there are a number of use cases we have identified for RedCap around wireless industrial sensors, Fixed wireless access is a popular offering because of that ability to tap into 5G spectrum and take load off 4G networks. Smart grids, we see interest in smart wearables like watches, and increasingly laptops and tablets too. Perhaps one of the other, alongside fixed wireless access, key initial use cases appears to be around connected cameras, where the capability of RedCap is very, very attractive. And again, being able to put that onto a network slice is also a key advantage. Globally, we see 5G RedCap now arriving. We have 30 operators in 21 countries investing in 5G RedCap, although to date, only 6 operators have launched 5G RedCap services in Kuwait, in the Philippines, in the US, and in China. There is momentum and interest around this, but it is still an early technology in terms of global rollout. When we look at the investments in RedCap by region, Asia Pacific has the greatest share of investments. Middle East is also a key area where we are seeing RedCap momentum. Europe, a bit further behind, as is North America and Oceania. In terms of the ecosystem, there are a number of chipsets we've identified from Qualcomm, MediaTek, Unisoc, and others. This very much offers the capability to offer that range of devices. And the devices we have tracked so far in our Gambol database are 25 different commercially available devices that use RedCap. So we think this is an important technology, particularly for IoT use cases or for applications where there is benefit in migrating away from 4G technologies because of that ability to tap into 5G capacity or the 5G management capabilities that connecting to the 5G core enables. Yet by lowering device costs, by reducing the brand antennas, reducing the processing power, it makes it easier to make 5G technology available cost effectively. We're also tracking 5G Advanced. Now, this is the brand name essentially for the second half of the 5G era. It's based on Release 18, which was standardized in June 2024, so a year ago now. And this is similar to what we saw in the LTE era with LTE Advanced Pro, or in the 3G era with HSPA and the so-called 3.5G branding. It has a range of capabilities that improve positioning, energy performance, latency, improved non-terrestrial network integration, and it also offers another flavor of RedCap called eRedCap, which is even more capacity constrained, but even cheaper and widens the market opportunity for RedCap. And that's a feature of 5G Advanced. When we go on and look at this, we see advantages in mobile broadband, in network efficiency around the energy performance, the positioning piece. Again, integration on a standards basis with non-terrestrial networks. That starts with Release 17, but there are significant additions and improvements in 5G Advanced. There's also device-to-device side link communication that comes through as part of the 5G Advanced standard. So there's a range of reasons operators will look to deploy 5G Advanced. But again, because the standard was only finished in June last year, we are at a very early stage. We are tracking 26 operators in 15 countries that are investing in 5G Advanced. However, most of the investments today are taking the form of trials and tests. Globally, we have identified 6 operators that have launched services or features based on 5G Advanced and are marketing them as 5G Advanced. When we look at the global reach of 5G, we see activity typically in the markets you would expect to be leading markets, like China, the US, parts of Asia Pacific. However, there are some notable other markets which are early in their thinking on 5G Advanced, like Turkey, Saudi Arabia, and India. And I think some of that is because markets like Turkey are late to launch 5G, but because they are late, they are launching directly with 5G standalone. So they're skipping that initial phase of 5G of using the 4G core network in non-standalone mode. They're skipping that and skipping straight to standalone and the second part of the 5G era. And that, I think, is why we see a market like Turkey being early in their thinking on 5G Advanced. When we look at the chipset support, it's quite interesting. We have the M90 5G modem for MediaTek. We have both last year and this year's chipsets from Qualcomm. Notably, when last year's flagship Qualcomm chipsets launched, they were Release 17 capable and Release 18 capable, but Release 18 required a software update because these chipsets launched before the standard was finished. This year's chipsets, which are used in devices like the S25 range, are Release 18 capable initially. And again, when you look at the devices compatible with 3GP Release 18, that means that devices like the Xiaomi 15 range, the Galaxy S25 range are Release 18 capable. Last year's S24 range has that older modem that is Release 17 capable out of the box, but needs a software upgrade to be Release 18 capable. And that's why we haven't listed it on this slide. And all that is in the Gambod database. We also track non-terrestrial network support. And again, 3GP Release 18, 5G Advanced, improves the interoperability between non-terrestrial and terrestrial 5G. In our database, we are tracking 21 partnerships that are currently testing, 31 are planning deployments, and 9 have launched. So these are standards-based offerings between operators and satellite vendors. And this, again, is from the Gambod database that is available to members of the GSA. So our perspective on 5G Advanced is it really does move forward 5G. It's also striking that 3GP has chosen essentially a brand name for this version of the standard. And this gives operators, I think, the opportunity to relaunch 5G if initial 5G services have any negative sentiment around them. It enhances operator value through automation, improved latency or responsiveness, improved uplink performance and energy efficiency there. It opens markets in automotive, smart cities, smart agriculture. And it's something that I think will be a key thing to watch over the coming years. The other piece that we track at GSA is the long-term evolution of the industry. And we track what's happening with 6G, where standardization started in Seoul in March. We see 5G Advanced as a stepping stone to 5G, and we anticipate the operators that deploy 5G Advanced will have a much easier upgrade path to a 6G network than operators that do not. There is a good chance, we think, that because the industry is so focused on making 6G a straightforward upgrade and avoiding the problems and pain points of 5G, that it will be a much easier upgrade than many are expecting. But to do that, operators need to move on to a 5G core network, a modern architecture, and have deployed 5G Advanced. So I will thank you for your time today. I'm open to questions if we have time. I'll let the moderator inform me if we have. Our contact details are there. All the data in this is available to our members, and I would welcome all of you to investigate joining. It is a great organization to be part of, and we have a number of special interest groups covering topics like RedCap, Spectrum, standards, and so forth that will be of interest, I'm sure, to attendees of this event.
Okay, thank you, Ian. I have just one question for you. Based on your map, I saw just only one country from our region, Central Asia, just representing Uzbekistan. What do you think? What about the future of our region, which just I don't like to say the start moving to 5G, but still thinking to moving forward?
So I think what I alluded to is that 5G technology is something which is obviously moving forward every year or two. Initial 5G services launched in lead markets back in 2019, based on release 15. We now have release 18 available. So there is tremendous opportunity, I think, for operators in markets to, as I said, leapfrog those early painful bits of 5G and actually move ahead of some of the markets that might have been early with non-standalone services, but haven't really done anything interesting. The challenge with non-standalone is it only really helps boost mobile broadband speeds for smartphone users and adds capacity that opens up fixed wireless access. It doesn't help with all those other industry use cases in vertical sectors, different parts of the industry, where if you have standalone, and especially if you have 5G advanced, you can add significant new revenues. And I think operators launching later will probably go straight to standalone.
Okay, thank you. But still, as based on your data, just only 6 mobile operators on commercial way and 21 operators still testing 5G network. What do you think? How we came a little bit more with commercial?
That's with 5G. That's with 5G advanced. I think there's a lot more momentum with standalone, and on top of standalone, we are tracking usage of things like network slicing, RedCap deployments, and standalone itself brings a range of benefits to operators. I think the reason 5G advanced has modest adoption to date is just it's really, really new. It typically takes about a year from the standard being finished to most operators launching it. We are under a year from 5G Advanced being finished in June last year. We already have six launches, which I think is actually quite a positive move.
Okay, thank you. Есть у кого-то еще, может быть, вопросы из зала?
Do we have any further questions? If there are no questions, let's thank our distinguished speaker.
Следующая презентация.
Our next presentation is Alexander Gulaev, the head of the working group on the frequency range working group. Thank you, Shafkat, for the introduction, and I'm also grateful to ComNews for the opportunity to continue with the relevant discussion that was started several years ago. In the light of the decision of ITU, basically 6 gigahertz range, I would like to talk about some of the developments that have happened since the moment of identification of this important frequency bandwidth, speak more about standardization in ecosystem. The part that in the previous presentation, my presentation is going to overlap with Stefan's presentation. Stefan's presentation was more like a backdrop. I would like to tell you about our movement towards 5G advanced and 6G, which Jan told us about. Well, very briefly, we'll take a look at the continuation of the topic that Jan covered, the development of 5G advanced globally. Then we'll focus on 6 gigahertz range. Let's take a look what's the current trend out there. We'll pay attention to the BRICS countries and the other pioneer country who are preparing this frequency range for the commercialization, and also cover the topic of standardization of 3GPP. It's also very important. We'll see the partnership of industry in preparing IMT ecosystem where Huawei is an active participant. Then this is the slide which I added for you to be able to see the scale and ambition related to 5G Advanced. Jan provided quite some detail about this, and the Chinese operators have some great plans to implement these intermediate technology, which will help to move to a substantially better level of quality of customer services. Jan covered two versions. Release 18 was released half a year ago. 5G Advanced is just a child which is under 1 year old. And right now they are still testing, do test launches, and more than 60 operators globally announced about the commercial plans, and half of them will start deploying this year. So the time from the announcement to commercial implementation is very short. And the second point I'd like to note about the 5G Advanced, let us focus on this. Some big changes have occurred in uplink channel. With time, we note that the networks become more interactive. More and more requirements is applied to the download speeds to ensure the equal communications between the uplink and downlink channels. This is an important change. And second one, positioning. 5G Advanced, much more precise positioning that enables to discover these new opportunities. Also, I'd like to note in the Middle East, I use the 5.5G. This is equal to 5G Advanced. Simply commercial reflection of the technological term for the marketing purposes. It was introduced by our company, and at this point of time, it is being used very actively. I'd like to know that in the Middle East and the United Arab Emirates, Oman, Saudi Arabia, there are big plans to use 5G Advanced. And also as part of today's discussion, in the United Arab Emirates, our operators got 350 gigahertz of 6 gigahertz range, and this could become one of the more remarkable events in the mobile world, because with such width of the channel, they will be able to implement all of those beautiful capabilities that are being standardized by ITU with 3GPP. Let's start the quick movement from the point when the 6 gigahertz range was identified for IMT with active support of RSS regulators. And we are really grateful to the region that right now there are some technical capabilities for the use of this bandwidth, and this is basically reflects in the use by the other services and agencies in a new technical format. For engineers, it might be interesting technical terms expressed in the expected mask aim. Expected ERP mask, precisely. This is a new approach to defining the terms of the frequency range that helps to combine ground services with the satellite services in the frequency, in the reception frequency range. After this decision, we can see a much greater interest that is applied to the upper frequency 6 gigahertz, 625 megahertz to 7,125 megahertz. The lower range 6 megahertz is used who is planned to be used as the expansion range for Wi-Fi, while the upper frequency range is going to be used by the IMT systems 5G Advanced and 6G. Also, would like to note that there is a RSS frequency for the CIS region, where there is a frequency plan for the use of this frequency by the mobile networks. What is happening globally, and a brief overview. Let's go region by region. This frequency range, the BRICS countries, Brazil, Russia, China, and India in the last week, we learned from the official source, made the decision in favor of IMT, 5G and 6G above 6 gigahertz, which is probably an indication, a signal for the regulators in the region, since there are very close economic ties amongst the BRICS countries and the CIS countries. Apart from UAE, where 700 megahertz, 350 megahertz was given to the operators. In Brazil, the licensed 6 gigahertz licensing is planned for 2026. The other countries are also energetically moving towards this range preparation. In this region, we know that in Russia and Uzbekistan, they're planning to update the frequency distribution table, where this band will be given to IMT. And in Kazakhstan, a company back in January did the successful testing of this technology in Astana. The field tests or testing, it happened not just in this region, in multiple locations. The leading operators expressed their interest to learn how to include this frequency range into their infrastructure. The important point right now is expressed in the point that was also raised by Stefan and Leonid asked this question, to potentially combine the C-band sites with the 6 gigahertz sites, because the frequency difference almost 2 times. How can you combine these sites, the same sites, with the seamless coverage? Well, there is no big secret here. You cannot cheat nature, you can only improve your technology. The following improvements of the technology are available. Improve MIMO size on the channel down, bigger antenna, and the intellectual antenna, the so-called AAS, active antenna system, when the antenna with the active beam management, instead of equally radiating energy across the entire cell, when the beam goes straight to the user's terminal. So the range becomes greater. Certain improvements in this part, antenna on the part of the terminal, 5G Advanced, this has been the first step towards this. It's also important the frequency bandwidth. You can expand, the greater is the frequency range, the more power you can transmit in this channel, and therefore increase the coverage, increase the distance. The tests demonstrated this in 6 gigahertz coverage that wasn't inferior, but in some cases it was superior to the C-band coverage. So this is highly prospective for the operators to plan applying the 6 gigahertz cells to the currently existing network of cells. This slide indicates how we tested this bandwidth in Kazakhstan. We used the 400 megahertz channel and reached the speed over 10 gigabit per second in a stable fashion within the small testing zone. This is comparable to the speeds that have been achieved through the general specs in the other tests, but this was one of the most recent interesting tests. Very briefly tell you about the standardization. There is this term SDO. SDO, this is the organization that develops standards, standards developing organization. These ones are related to the spectrum regulation at 3 levels. As I try to show this on the slide, there is the international, the ITU, they develop standard recommendations. There are national regulators, regional organizations, all of these 3 levels for the spectrum regulation. They interact with the organization developing standards because you can't move along without any standards. Business's capabilities will be limited. This is a historical document that I found. It's an ancient one dating back to September of 2020. This was the inquiry from RSS regulators for 3GPP to start work to standardize 6 gigahertz spectrum, working on the specs 5G and RSS as these people were at the beginning of standardization of this frequency range. So, but this document, they initiated this work on 3GPP. The spectrum was included into the overall spectrum of FR1. FR1 is described in the specs 3184. In the bottom table, you can see this. You can see various frequencies for uplink and downlink, TDD. Frequency. Just a couple of words about 3GPP performance as reflected in the International ITU conference. Well, this is also important for the regulators. The terms of reference for the use of these frequency by IMT. These were formulated as the expected EEIRP mask. So you can see the breakdown by sector, by azimuth, or by bearing, the location angle, and summarizing the energy that is being emitted to the specific sector. There are certain limits that are specified in this table. And the operators, when deploying this network, because these terms will be specified in the license, they must comply with these limits. What are the advantages of these limits? They give you a possibility to protect the satellite reception by limiting the level of signal transmission from the station towards the satellite. So with the increase of the location angle, the power output that is allowed is declining slowly. So the satellite reception might have some expectations with regard to overall aggregate level of noise that will be coming from these newly commissioned systems in the 6 gigahertz. 3GPP also did some work to standardize these activities for the regulators. There is a tool that is furnished in the form of a separate technical document, methods of compliance testing for the transmission of the supply of the base station's EE mask. The operators who are going to use this particular frequency range, this is a tool with the help of which they will be controlled, making sure that the terms of reference that issued are complied with. On this slide, I simply show you a brief overview of what's been done by 3GPP with the links. I simply would like to draw your attention that about a month ago, in April, the RSS meeting, they started to initiate this early work to standardize this range to reflect on the documentation of 3GPP in the regulatory documents of the Commonwealth. So when the time of the commercial launch comes in, all of the regulatory framework must be ready. For the ecosystem, a couple of slides. It has been noted that globally they escalate the work on chipsets and finished products. At this point of time, we expect the finished commercial CPE for fixed wireless access, which would like to start with at the end of the next this year. Maybe one or two smartphones will appear supporting this range, and maybe in a couple of years' time, based on the outlook industry, smartphone industry, we can expect some flagship models supporting these functions. Our solutions, I also added these to the slides, which we are preparing for the deployment in the United Arab Emirates. The commercial AAU block for 6 gigahertz, 400 megahertz channel. This one is ready, and by the end of the year, at the beginning of the next year, we're planning to supply our client with this equipment. The last element I'd like to note, in the industry there is greater support towards the use of this spectrum, well, based on the reasons that Stefan mentioned in his presentation earlier today on this range. From the most recent events, May of 2025, we can see the open letter there are European telecom giants to the European Commission about the critical importance of allocating the spectrum. Based on the logos, you can see about the real support for the spectrum. The last slide, our recommendations, what we discussed, based on what we discussed with you, in line of the decision of the global conference, we recommend the regulators to reserve the spectrum as the strategic spectrum for 5 and 6G development in the future.
Спасибо большое.
Thanks a lot. Since we are pressed for time, I would like first to hear all the presentations, and then after the presentations, we will have a Q&A session. If there are not any objections, I would like to turn the floor now to Temirlan. He's from Freedom Telecom Operations. Please. Temirlan, you are welcome. Yes, everything is working fine. Shafkat, thank you very much. My name is Temirlan, and I was invited to talk as the representative of Freedom Telecom. I'm more involved and specialized into the cloud solutions, but I can make somebody else's presentation. Could you please demonstrate on the screen my presentation? Meanwhile, I'll give you a little bit more information. You know, I'm very fond of Huawei because their presentations are always very interesting. You will hear everything about the physics laws and the government laws. You know, everything is very well defined. And they don't sell anything, you know, it was a compliment. Sometimes we want to buy something from them. Well, maybe meanwhile you're going to tell more about Freedom. Of course, we've heard a lot about Freedom, but maybe you will tell us a few words about cloud, and then you will start your presentation. Yes, of course, you know, in the establishment of Freedom Telecom was not a chaotic and odd solution. You know, in fintech, we are providing very good solutions, and the bank is growing year by year. For example, last year we had a growth of clients by 6,000 people, and Freedom Telecom is growing in terms of the number of users as well, because this year we are 1,500 clients more. You know, people are using internet, telecoms, and various services. And this is the reason for which telecom is a very important sector for us. But the other sectors of our development are also spinning some new development vectors. And for example, Super App or for our ecosystem. Right now, in the framework of lifestyle, we are considering a possibility of delivering goods by drones. But of course, for all this, you need telecom and IT, and Freedom Telecom is the company which is a part of a big holding, and the company itself is American. We are listed in NASDAQ, unlike the majority of our competitors. So our stocks are listed in NASDAQ, and therefore we are fully compliant with international financial reporting standards. And you know, there are some very rich people, but our investors are not very rich, but they're also very lavish because they're ready to invest. And, there are some representatives of Astel. They used to be our competitors. Now they are our colleagues. Somebody will have to think if you will buy or you will be bought. So our company has a lot of very interesting cases, and some of them are pretty sustainable. And talking about Telecom, we are very actively developing not only in Almaty, Astana, and Shymkent. We understand that it is very difficult maybe to elbow our way among the competitors, because it is rather very difficult to become operator number 5 or 6, because the break-even period is going to be very long, and the client will not be surprised by any of your solutions, because the internet is the same, the channels available and telecom links are all the same. This is why we are trying to be more present in the regions that are not covered by big operators, and we are also involved into the development of the infrastructure. We are very actively developing the FVA. We really trust in this area, and we have already deployed it as a pilot project in one of the micro districts in Almaty, which is called Arbita. And our peculiarity is that we are a kind of vacuum cleaner, because we are hunting after people who are really very good experts in telecommunications area. Now, the tendencies that we are looking at, of course, these are AI, and in the framework of AI, we have a very good platform. It's our sandbox for the whole holding. The bank, the brokers, they have a lot of data based on which we can test our hypothesis, because AI is present everywhere, but probably nowhere except for GPT chat. My understanding is that 90% of the time that I spend is in GPT chat. And I think that GPT chat has a lot of opportunities. With Astel, we will also develop our satellite competences, including among all, not only the cooperation with Starlink or OneWeb. There is a very cool idea that we have, because we would like to transform the current relationship, because right now the government is very much focused on ETS Go, even though it is very archaic, because you should not protect your perimeter, your infrastructure. You should protect your perimeter, and therefore, based on the example of Big Four, they have a lot of various employees all over the world, and they are involved in different things. But the key point here is information that they have. From my point of view, and it is my subjective personal opinion, ESDT is a little bit obsolete, and I'm pretty sure that many Kazakh Telecom specialists will probably condemn me for this. But for iCloud, I'm ready to discuss any case and every case with you. And why we are looking at the cloud as well, because it is a very big story. There are not ready-made solutions. You cannot take OpenStack or open source, because you have to do something. And even the great Huawei is not very helpful in this regard to us, even though they have a huge cloud with about 570 services. But even their services are not satisfying all our needs, and this is why we are engaged into multi-clouds. We have VMware, open source, Open Apple, and we have Red Hat and AWSO. We are official partners of AWS, and we have various areas of activities inside the holding on the payment systems and data storage. IoT is another very interesting solution, because here we are collecting all the data and information, and very actively working on the protection of SCADA. For example, in our industrial facilities, in our industrial companies, there is installed SCADA. But it is not very well protected. Sometimes when people are inside of the perimeter, they believe that it is very well protected, but there are a lot of cases in other countries of the world when, the some fraudsters go inside, scatter, and they do a lot of harm. With regard to AVR, VR, it's also piloted by our company as well. With regard to AI, I can tell you that it is used almost everywhere, and there was a very interesting study on how the I would say 30 people and older, 30 years of age people and older, how do they use GPT chat? They use it as a tool which helps them in their everyday life, and they do not treat it as Google. And people who are 30 plus, they treat it as Google 30 plus. People do not say thank you to GPT chat, but people who are younger than 30, they really express their very deep feeling of gratitude to ChatGPT, and they treat ChatGPT as a friend. And for all this, of course, we need a very good internet, and I'm really very happy about Gemini, which is a Google instrument and Google tool, and we are maintaining a dialogue with Google right now, and I think that this trend of using AI is very interesting. With regard to the challenges that we are facing, when we were thinking about telecom, we thought, okay, there is Kazakh Telecom, the great and powerful Kazakh Telecom, and let their stocks not drop by 20% per week. But, their networks are obsolete, getting obsolete, and the ownership cost is pretty high. And, me as a gamer, I don't like to let's say, play in PUBG because, you are trying to fire a gun and, nothing is happening. And by the way, at home, I'm using Kazakh Telecom, and geopolitical problems as well. We, as Kazakhstan, we have two channels, and Russian channel is the main, Chinese is optional or additional, and jointly with Kazakh Telecom, we are working on the new digital corridor, which is actually Trans-Caspian route, and there is cable, and Freedom Telecom is laying down the main communication link through the Caspian, and then all the way to Russia and Europe. And, Kyrgyzstan, Turkmenistan, and Tajikistan will be using it, but there are some vulnerabilities. And, for example, recently, internet was disconnected in my house, and unfortunately, a fiber optic link was damaged, and therefore this type of vulnerability will always be in place. We signed a memorandum. We are investing in our projects, but the government is providing regulatory support, very active regulatory support, because they give us an opportunity to discuss with foreign partners on the platform of the government, and we jointly pursue our goals. And our main task is Freedom Cloud. We are trying to make sure that all the services of the BT companies will be here, and if they are using the networks, they will be using the most advanced networks that work without any delays. And here is our backbone network. We are very actively working on them, and there are two types of CODs and Tier 3, and there are containers as well. And as I have already mentioned before, we are building up the multi-cloud because we don't want to put containers everywhere all over Kazakhstan. And we are trying to be very selective in terms of the selection of the projects, their implementation, and their allocation. Here is the example of how our colleagues are constructing and laying down or constructing the networks. Here is an example of Almaty region, and the approach is really very good, and there are a lot of life hacks, some non-standard solutions. Here is my love number one in Astana, and the second one in Almaty. With regard to Astana, of course, I can talk a lot, and the main difference from Almaty sod is because we would like to have 1,000 racks and one block on water cooling with water cooling for AI, and there is a license to purchase the cards. We have already bought 40S. But why we are not proposing them to the market? Because we believe that the market is not yet ready for the use of these cards. Because when people keep wondering why do you need this infrastructure, what are you going to do? Looks like everybody want to deploy a DeepSeek or to have their own chatbot. This is why we do not trust these stories, and we are more involved into holding or our own projects. And we are working on Alem AI, KazLOM. And Almaty sod is different because its peculiarity is that it is really very, since we are constructing it in Alatau IT Park, it has a very resilient power supply system. And even if somewhere in Almaty there will be a blackout, or if an earthquake, a terrible earthquake will take place, there we have, a lot of reliability, and we will not be facing any problems in terms of possible consequences of the powerful earthquake, and which is why Almaty Airport is located right there, because the terrain is very solid there. Our tactics was like this. We were occupying some places where there are a lot of people, for example, the squares and the airports. And now we are looking at various districts of Almaty, as I mentioned before. We are deploying our free Wi-Fi, for example, in Arbita microdistrict. So if you visit this microdistrict, please feel free to use our Wi-Fi. And there are some M&A transactions, deals that we have already completed. We have merged with Astel, Elite.com, Silknet.com, and this means that the guys are really very powerful, because Astel is already 23 years old, and Elite.com is mainly specializing on the main links. And if you have any questions to me, this is it. Thank you very much for listening to me. Thank you very much. And if you have any questions, I will be happy to answer them. Thank you very much. And I would like to speed up because the next presentation will be made by Ivan Gurushev on the complex monitoring of infrastructure and telecommunication links of Kastranzoil. Thank you very much, dear colleagues, for the opportunity to speak at this very nice event. I will say a few words about our company, and we are available for 12 years. We are present here for 12 years, and we do a lot of automation processes and projects, and we are interacting with various big infrastructures, which consist of 2 million devices. But maybe one of the cases that I would like to tell you about, well, just a few words about our company. It's now an ecosystem, the prerequisites for project implementation, technologies that we apply, NNM in the project, ICT on monitoring, and then I'll be talking about the peculiarities of the project, and by the end of the presentation I will be talking about the key results. Nauman is the Russian company. All the developments are located there in the Russian Federation. There are about 1,500 people working in the company. We are very well known in the Russian Federation from the point of view of the automated systems and automation projects, and now we are working on the projects dedicated to infrastructure control and everything that is associated with infrastructure. With regard to this ecosystem, As a matter of fact, all our customers, they have their own vision and their own technologies that they're using for automation of certain processes, and to maybe simplify some of the components to make the process inside the company more transparent and available, not only for the users of the infrastructure, but also for the external users and the management of the company. And therefore, NetPro Manager is in our system the key source of data, which enables us to get integrated with whatever. And initially, it was intended for the possibility to get connected with base station servers or any other components of the infrastructure. And in the course of such connections, we have to have an opportunity to monitor the status of each component. And with regard to the partners in the territory of Kazakhstan, it's LLP Arna Telecom, and they expressed their task. They would like to have one tool for monitoring of the whole ecosystem. It's not like, there should be the whole range of various monitoring tools for different components of the ecosystem. The idea was to get access to the whole infrastructure and be able to control and monitor it from one window, so that it's one holistic system which is working with the infrastructure, with pretty complicated server models, which will make all the internal processes transparent, and to cover all the devices and equipment which is operated by the company right now, and making sure that this infrastructure will be evolving and growing. And one of the tasks that we received is to control CPC and to develop the service model for throughput channels.
NNM technologies that have been used in the project. NNM basically a boxed product where you can have these whole functionality. We only used that functional part that was needed by our customer. We did the automatic discovery of all of the devices in the system, and as we launched the project, it was discussed we're not trying to cover the entire infrastructure of Kaztrans-Oil, but we covered the entire zoo of devices. All of the vendors that have been present, base stations, network devices, engineering networks, everything has been covered. And the technologies of resource and service models have been designed. User roles have been identified because they can see the whole picture, but the management must see the whole picture. We did the integration with the Zabbix. It's a normal story when the customers want to keep the resources in which they invested previously, but can have some sort of upscale. Zabbix covers a specific corner beautifully, but it's got the complicated automatic discovery within NM. It can be done very easily. We have hundreds of thousands of devices, and the database gets updated all the time. All of this is based on the GIS topology of the network. syslog processor was designed in the panoramic representation. This is the technological coverage, the network and telecom equipment, all of the communications equipment, servers and working stations, Linux and Windows systems, some Android systems, engineering networks, engineering systems, power supply, climate control, and so on. Automatic discovery. Why I want to mention this again? Because we study a lot, we study markets, see what products are being developed in Russia. You can see as our customers more and more often come across one thing. The monitoring, it seems to be available and seems to cover various areas with various solutions. But the single tool that would enable them to have the whole infrastructure, all of the addresses, being able to build automatic connections between devices, synchronization with the CMDB, synchronizing data compared to the basic configuration. This tool has been well set. The system operates by schedule, redistribution of spectrum. The nighttime, the system operates when the minimum network activity. Morning, the operators come, and they added 3 to 4 new servers. It can be done or discovered using various protocols combined, SMDB, CMDB, or by means of agents. And of course, in some cases, this is some sort of an integration. 3PM var, when we need to look through the entire structure, this is software. The example or the case of the resource service model, we built the automatic monitoring channels, changing throughput, changing interfaces, utilization, port changes, config, device control, deviation control. All of these was gathered in small resource service models for each individual channel and each individual resource service model. We have the service, we'll need to control its degradation. If we have one channel falling, the backup channel is functional, we get a notification that something has gone wrong, something happened to the interface, some balancing system lost some config. So we visualize all of this, we see, we get notifications in real time, and we also set the predictive analytics. Not overcomplicated, but helps our people at all times, because based on any active metric, we can do the forecast, can do this on historical data. On the first day of implementation, that wouldn't happen, but after some time, as the system accumulates data, based on this data, the system is capable of forecasting, which simplifies the work from the standpoint of prediction, looking for the cause. As Zabbix integration, we have a ready interface. In this particular case, Zabbix, we are working with various systems, cybernetics, Prometheus. We can integrate this when the customers don't want to have any extra monitoring tools for the areas which are already being monitored, but they need to get relevant information in a single window. Geofiltration, configuration versions, all of these is being supported. Additional thresholds are applied. At the Zabbix and our level, we get notification. All of these has been delivered. Panorama visualization, this is more of an entertainment on the one hand, but on the other hand, the network person or the network administrator of the open web interface, open a panorama, which they can come across. In Red, you can see the status of different devices. This is the mask that is connected to specific devices, so simplifies the data gathering for a specific router or server that requires some services. In some of the key implementation results, 50% acceleration. This is because they're all being visualized, and there is a possibility to debrief everything straight from the interface. You can see lower downtime. We optimized the manufacturing, the throughput of the system, improved interfaces, look through the conditions of the equipment, identify any bottlenecks that require some help or replacement, and by 80% we reduced the labor costs. Looking for the causes of specific events, configuration control, and the whole equipment servicing cycle. All of this has been achieved. And this is it, colleagues. We'll be happy to take your questions. Thank you. Since our time is almost up, I suggest that we listen to the last presentation by Sergey Afanasyev. digital telecom infrastructure architecture. Hello, first of all, I would like to thank the organizers for this possibility to speak for the third time in this conference. Last year, I had a similar presentation on this topic. So today I'll try to expand this and add more elements. The top-tier architecture that is presented here is simple conceptually. And one single service level is identified in the system, which is responsible for all of the services, revenues, values, and we add two auxiliary levels: the connection level for customers to the service, connection to the aggregation level, and internal transport level that connects these elements of the transport level. Specifically, if we talk about the cloud-based technology data centers, this concept is not new one. It's been known as the three-layer model proposed by Cisco, but there are several principal differences. Number one, the service level is fully implemented via cloud, the cloud-native approach. The first key difference. Number two, levels A, level C, access and transport, they are simplified to the max, basically down to the photon level. No electronic equipment is allowed to make sure that all of the elements of the system are as cheap as possible, as scalable as possible, continuing to develop the ecosystem in general. Yet another difference is that at this level we use the most simplistic physical topology. I'll make a reference to this on level A. This is multi-point to multi-point connection. The level C, the connection point. This approach enables us to implement these network levels and exclude complicated functions such as routing, traffic engineering. This particular architecture is universal because of the longer distance communication, because of the photon-based technology, which enables to include all of the customers, regardless of where they're located, either in the remote areas, small cities, or large centers. Level C, the data center level, basically this is its own hierarchy. It's divided into internal cloud and the global clouds. Inside that, on the private cloud, there is its own hierarchy. You can imagine three levels, three tiers: operator, periphery, data centers, each computing which can be located not in the buildings but the outdoor facilities. And various kinds of hubs, regional data centers and other data centers. So then there is a question: what will create demand for this new infrastructure? Why is this important and who does need it? For many of you, it's no secret that according to some analytical reports, there has been some data that traffic on the global networks, ocean cables, via hyperscalers or OTT, and the traffic exceeds the internet traffic, the internet service providers' traffic. And by 2030, this is gonna get worse. Digital traffic will dominate over the internet traffic. This is happening because of the transformation of the economy of things, economy of the internet. Why is this happening? There is moving value from moving data long distances to the applications used that is located as close as possible to the users. This is being done with the help of technological innovations, which ultimately result in the situation that radically reduce the cost of optics and electronics components, so it's easier to make electronics closer to the customers rather than concentrated in the small, huge data centers overseas. Previously, the internet used to be the main cost factor and the main value. We were buying the internet. Now the network is losing its value, and the network from global network that requires connection everyone to everyone is turning into the access network to the nearby cloud. So basically why IPv6 is needed. It was needed for the previous internet house-based, when everyone could communicate with everyone through the previous address space. Now the internet is becoming into the access network, is turning into the access network. As a result, a change in the economic model, there is some transformation of the internet architecture. We're moving from everyone to everyone, access to the nearby hub, and for the implementation of services for digital companies to connect data centers to each other. So the networks becomes a utility. Unlike utilities, the online services, their load is not growing. It's predictable. But for the network, there is more and more demand that above the network we need to launch new applications. This question is related to the network neutrality, dividing business into network companies, and maybe even creating the new model of the economy of the internet. But this goes beyond this presentation, so I'm going to skip it. Apart from the external backgrounds, there are some internal backgrounds. These backgrounds, how do they change requirements for the networks, for hardware? Why do operators use complicated routers? To work on the traditional internet when traffic needs to be taken outside, so you need to find for the exit points amongst the other points. There might be hundreds of those. In order to do this, you need to look through the tables where there are millions of routes, analyze millions of pathways. This creates a big load. It makes the whole implementation heavier. Well, the internet seems to be global, and we need to ensure the decent quality of service, the buffer capacity that would handle around trip time. Conservatively, it should be up to 200 milliseconds. This makes the interface is heavier. So the question arises, what if we no longer need this? What if the internet traffic doesn't really go outside, but mostly concentrates inside? We go to on-net and go down to the access network. When traffic doesn't go beyond BNG or packet nucleus. In this case, complicated routers are no longer needed, can be replaced with the simple devices, the high throughput, or you can do photon stuff using WDM. And there is a greater demand for edge computing. Hopefully, XR and VR will be based on this. The industrial internet will be based on this. This will require implementation of hybrid clouds or multi-cloud networking. This will require the logical programmable network that will unite all of the public and private clouds, which will use completely different technologies and even overlapping IP addresses. As a result of the network requirements and its services, dividing networks into underlay and overlay, physical underlay, physical boxes connection, overlay, connecting API, and the creation of API manageable in SDN infrastructure will provide all of the network resources as a code to ensure auto restoration and auto scaling. So what's the logic of this new infrastructure? What does it do differently? And how? The essence that through the digital transformation, technological, we move from the vertical integrated systems. Our infrastructure was developed for every industry, for every domain. In the digital world, infrastructure is going to be the utilitarian. Yes. And all of the elements will be implemented over this new infrastructure model as a service, not just in telecom, but everywhere. It's important to know that each of these infrastructural levels, node A, C, and T, can be separated into separate business. Innovations at each of these levels can be implemented independently. The key factor of success of these infrastructure, the capabilities can be implemented via photons without electronic transformation, routing, and so on. These technologies are already available out there, DWDM, the excessive, they can be simplified down to simple topologies, point-to-point connection at the level of access aggregation. Again, there could be photon networks. These technologies are yet expensive and rare, but there is XR Optics from Finera. They created the Open Consortium, with the help of which you can expect that these technologies will be penetrating into various access devices, customers' devices that will help to implement this. And these ideas will even go inside the data center, photon communication, replacing Ethernet, routing, fiber optic circuit switches. The example of this is Google Jupyter project, which implements aggregation of photon routing.
And I would like to give you the example of operators, and of course they are very numerous. But I would like to tell about the most well-known. The levels of transport A and access are still a little bit limited. And TNT recently acquired Lumen, and Lumen was very well known for photon access and transport, and they're using the EXA candle based on gigabyte lambda use. And here I'm going to give you an example of cloud node, which was put together in Kazakh Telecom for the first virtualization based on OpenStack. And now, probably you know, in Untemak, 70 kilometers away from Almaty, there is a pilot operation of pilot RAN 5G network for implementation of fixed value at the high speed. And it's 80 megahertz, and the bit rate is up to 870 megabits in downlink. Just for comparison, the subscribers were using ADSL, therefore you see that the bit rate is twofold higher. Also, we are working on similar digital optical access, the so-called Volta, and eventually we will be combining these architectures, and we will implement over 5G the nucleus package, and it is very well adapted for the use of AI, of which we have already heard a lot, and the traffic of AI can be subdivided in big language models into the connection traffic, and for example, chat GPT, it's called inference, and at the same time it can also be used for trainings inside data centers for update, on remote operational centers, and for synchronization of models. And the additional load is pretty specific, and it requires it has very stringent requirements to delays, and therefore the backend network will have to be very much promoted. It's exactly the case like with Sun networks for storage, and now we are using InfiniBand fabric, and there are some updates which are already available for Ethernet, such as Skylab Ethernet or Ultra Ethernet is also providing its own specifications. And in addition, what is very important to be mentioned here is that in addition to AI services for end users, AI will be more and more used in various technological domains. And we already have the name of adaptive intellect intelligence, and starting release number 19, the first elements of these technologies are already introduced there, and their main difference is that without adaptive intelligence, the network parameters will be fixed statically for the worst case, and for all scenarios, the KPIs will be exactly the same. This means that they are bringing everything to the same determination factor, and KPI will have to be kept in the same criteria. In other words, they are using the data from the measurements that will be collected in the network, and they will have to understand the most optimal parameters so that you will be able to wait for a concrete, for a precise application. The efficiency level is going to be much higher. In this case, such architecture, when we are extending it towards backend, is really expandable. And there is one more very important issue. What we are doing right now is that we are working on the architecture for this three-tier architecture. And the question is how to implement the orchestration and automation of all these levels. We understand that the microservices should be on the bottom, but what is going to manage the virtual functions, CNA, and technological domains such as auto-run or 5G, the nucleus, and probably the first thing that we started thinking about is to use the same architecture for the virtual as for the virtual machines, because there were some elements for the container implementation that have been demonstrated here. Sergey, I'm awfully sorry, but you have already exhausted your time. Let's get to your last slide. Yes, as a matter of fact, it's my last slide. What we recommend is to pay attention if people are interested in it. There is the so-called Nefio project of Kazakh Telecom, and we are implementing in reality the CRD and control operators. If you are interested, well, this information is closed, but you will be able to find it. And finally, if you are very much interested in these topics, I'm inviting you to my Telegram channel, because this is what I'm highlighting on a regular basis. And of course, thank you very much for your attention. Thanks a lot. Well, unfortunately, we don't have any time for the discussion, but nevertheless, what I actually picked up from the last presentation is that all the layers, all the levels should be photon. What kind of level, what type of photons? I think that it's high time for us to break for lunch, and let's discuss it during the lunch.